So, hello everyone. My name is Svetlana Valger, and I'm part of the research team from Computational from the Stuttgart Technical University of Applied Science. First of all, I would like to say thank you to organizers. It's a big pleasure for me to be here today and present what we are really doing now, what are the current status of our projects. And today I would like to focus on the ICT Urban Transformation project, which has been developed in our university since 2017. I would like to divide my presentation for two main parts. And the first part, I would like to say some short overview, what is our motivation goals and the project types. And as the second part of my presentation, I would like to show you some examples. It's kind of pilot projects and demonstrator. It's a framework of ICT concept. So, and I think the motivation is very transparent because we have to reach the global UN goals, and I would like to give us attention, and we want to have a chance to achieve the UN's global goals. We need to get our cities right. And so I believe that universities can, as far as we can bring some deep research background into this technology to applications, I think universities can play a very significant role in the process to get our cities right. First of all, I would like to show a short overview. ICT Intelligent or Intelligent City is more than one research project. It's more kind of the research concept and research partnership, which is developing innovative studies, technologies, software, products, services, and frameworks for livable, intelligent, and sustainable cities of the future. Currently, more than 50 researchers at HFT Stuttgart are working together, different parts of the project, and more than 45 partners from industry and academic institution work together in different parts of the project. The intensive phase of the project was finished in 2024. That's why today I could show you some results and pilots. The main focus and the main research fields of the project are in mobility, energy, simulation and data, and buildings and infrastructure. Here I just present 8 of pilots or 8 of the projects, sub-projects. Main of them are focusing more on infrastructure to prepare in 3D models for buildings and building information models and city information models. I think it's the most focusing, and we have also some projects where we consider different kinds of applications for environmental problems. For example, we focus on air quality simulation, noise simulation, also a kind of pollution in cities. Today I will present some ideas. What could be the main idea, the main base of such a concept as an ICT? That's the digital twins. Today we are discussing a lot about digital twins at urban scale. And here I just would like to say that a digital twin is not a description of some physical objects like buildings or terrain or some infrastructure objects. It's also not physical things like a description of some processes which can be even not exist right now, but we need to integrate it into our model, such a possibility. So a digital twin concept is the main concept which we use to develop all the framework and technologies in ICT project. In the most classical definition, digital twins at the urban scale, it's a geospatial technology and data, but we can also say that it's some kind of sector-specific fields like applications for energy, water, and mobility. Always digital twins technologies together should help us to make the right decision and to improve our social physical systems. In all our projects, we use this framework based on CityGML format. I can say that more common language to describe 3D data and with different levels of digitalization for city most relevant features of the urban environment, not only constructions like building, bridge, tunnels, and so on, but regarding transportation system, vegetation, vegetation zone, water objects, and many other things. And it's easy to use it as a base for urban environment applications. That's why we used it as a main language to describe the urban environment. So, and I would like to show some examples. I would like to start from the simple one. Why I say simple? Because today I see that in many presentations we have a CFD simulation or numerical simulation, high performance numerical simulation results, and in this demonstrator we used not a CFD simulation to predict acoustic parameters, but just to do standard calculations. And the main idea of the project was to check interoperability of technologies, how we could visualize the data from engineering standard calculations with a city map, and how we can visualize it for the user to reach our target user group. And the short movie demonstrates how it can work. We can visualize a noise map in city. That's not a very large area. And we could visualize it in 3D manner and as some 2D cross-section. It's a web interface, and that's open now. You could find it on the website. HFT Stuttgart later will show some QR code where you can follow and find information regarding this visualization tool. But the idea to improve an interface between the user and engineer, to show how it could look, how noise map can look, to improve the communication. Maybe a more interesting example, because here we already used some kind of CFD simulation. It's an air quality modeling. I would like to show a case study area that's a campus of our university in Stuttgart city center. And the idea was to develop a kind of framework and make a simulation inside under the micro scale, I can say, inside a campus, and predict air quality inside a campus near roads. And what's the most important thing is how to collect the data for this area. Today we have a very powerful tool for CFD simulation, but there are still a lot of open questions, like how we could collect initial data, how we can prepare boundary conditions, where we can find the data regarding pollutant sources. And one of the interesting and important questions, I think, is a validation, because we could visualize the nice pictures, but what the question is, if it's really correct, if we simulate it, and how we simulate it, and what settings and what numerical models we use. That's why validation part is also important. And what was the goal for this study was to try to validate in a real use case. We are currently doing this because we have some number of sensors at the facade of building, some building of our campus, and we also had the topo boxes near the road to count the traffic to get an initial data for simulation. So as I already mentioned, we use the CityGML 3D format and 3D model to prepare our geometrical data and terrain data. And as a main modeling view, we use CFD software with Reynolds average Navier-Stokes equations as a base equations. Or now we also use a large AD simulation tool for some things, but for some reasons, to reach very quickly the results, Reynolds average Navier-Stokes equations are much easier and not so time consuming. So for real urban configurations, maybe it's a good solution, at least at the first step. And we use a Lagrangian method to simulate a particular nature, and also we predict gas pollutant transfer. As I already said, one of the challenge is how to collect input data for any kind of microscale model simulation. Methodological data, okay, probably we could find methodological data, that's a point. But what about the traffic data? In our case, we used traffic data measurements from topo boxes, which we installed near the road, which is located near our campus. We used the method compared and the database compared to get data regarding the pollutant sources. And we used also statistical data from Baden-Württemberg, statistical ultrasound. Why we used it? Because our topo box measurements could classify our cars only for 7 categories, but we could not identify what kinds of engine we have and what types of cars we have. It could be like a passenger car, but we don't know what type of engine with car statistic we have. So we just supplemented our measurement data with statistical data and using a compared method to summarize everything. I mean that there are many steps where we have kind of uncertainty for such a simulation, and that's also an open question, because when we say that simulation is a very powerful tool, we should think regarding measurements and validation, and that's an open question sometimes, because some data are missing. The first visualization is were different kinds of application for that. It would be just a pedestrian comfort analysis. For that, we in general we need only wind velocity fields, for example. I think we could visualize the pollutant concentration as either surfaces or cross sections. So probably we could visualize it as a facet of buildings. That's kind of qualitative information, I can say. And as far as we simulate some scenarios, we could simulate time-dependent scenarios, and we can analyze what happened during the day or night time, depending on season and traffic conditions and so on. And the second part, it's a sub-project. I cannot say that they related directly the previous results in this part, but the idea was to prepare some kind of visualization tool to visualize the CFD data using CityGML models and web interface, and that's also first results you can find with the demonstrator on our website. Using a QR code, where we could check how user can manage and process data regarding pollutant concentration in city. That's really very easy web interface. We would like to improve it in advance. What is the question here is that when we speak about a user, we should understand that they don't know what current Friedrichs-Lewy coefficient is, number means, and they don't know what the time steps they need to use for their simulation, and some details. I think for users it's most important to understand, to make decision to understand how what can be changed if I change the wind flow conditions, for example, or add some building models. But it should be really very simple interface, and my vision is that users don't need to think about how they simulate it. They should think about the results. Finally, I would like to show you the first results of the project Inspire. It's also a part of the ICT project concept. Could you help me, please? And the next step, the first step, I just showed the first demonstrator where we visualize and web interface team standard calculation data for noise map, for example. As a second example, we used already CFD simulation, high performance CFD simulation, and visualize it in web interface. And the next step is to bring virtual and mixed reality in urban digital twins. And that's also kind of pilot project. The main idea is to use mixed reality to modify, for example, landscape, architecture, objects, and so on. There are a lot of really important research questions here, how to register cloud of points, for example, how to find zones of interaction between the real world objects and mixed augmented reality. Also, in our next question, the next research question, if we visualize it, how we can use it at the next step, how a user can use it. And here I can say our concept is that this data, which we model in our mixed reality, should be stored in a more or less correct way for engineers. That's why the research team in the HFT develops an interface how to store, process and store data from mixed reality in the 4 beam projects, like for example for Autodesk beam simulation in the advanced. Yeah, sorry, maybe I could put it here. No, it doesn't work. Okay, so it's not a problem. I think if you want to. I think that's all. If you want to follow us, if you are interested in what we are doing now, please follow us in LinkedIn, or you can also check out our website where we regularly try to show what the demonstrator we are developing now. And I just would like to say that we have very distributed research team, and if you are interested in some specific demonstrator, you could connect with our managing director of research management department in HFT, Andreas Schmidt. Because if you need some specific technical details from different projects, maybe it's a good start point to communicate with. Yeah, thank you very much. And I try to speak very quickly, sorry, because I know that we don't have so much time today. And if you have some questions, please, I'm happy to answer, or probably we could discuss some things later.